Hello friends, welcome back. Hearty welcome to you. In this session, let us look at method of intervals or Wavy curve method to find out the solution set of inequalities. To understand the method, let us take a simple example. X plus 2 multiplied with x plus 3 is greater than 0. Now suppose we have to find out the solution set of this inequality. What the method of intervals says is, first find out all the values of x which will make the inequality, which will make left hand side equal to 0. That means x plus 2 into x plus 3 equal to 0. We know that x plus 2 into x plus 3 will become 0 only when x equal to, so I can write down that. First we'll write down, we want the values at which the f of x will become 0. So can I say x plus 2 into x plus 3 equal to 0? That means either x plus 2 is 0 or x plus 3 equal to 0. That means we know x equal to minus 2 or x equals to minus 3. So these are the values of x at which the f of x will become 0. This is our f of x. Now what we want is f of x greater than 0. So what method of interval says is, method of interval says that just go ahead and put down the number line, start with minus infinity and go towards infinity. Now wherever you have the x values, whatever we got just now, let us say suppose I have x equal to minus 2, minus 3. So I know first minus 3 will come. This is minus 3. Then I will have minus 2 somewhere here. Now how to find out the solution set of this? For that, the method of interval says that pick a value, for example minus 2 to infinity. Generally my favorite is 0 because 0 is easy to substitute and check. Put 0 in the f of x. 0 plus 2, 2, 0 plus 3, 3. 2 into 3, 6 greater than 0. So f of x is positive here. So f of x is positive in the interval 2 to infinity. Now method of intervals says that if that is positive, then this will be negative and this will be positive. So that's why it is also called as Wavy curve method. That means it will be going like a wave. So it will be going like a wave. So we have now positive values and negative values and positive values. Let us cross check whether this is perfectly correct or not. Suppose you take a value between minus 2 to minus 3. Let us say x equal to minus 2.5. Now let's go ahead and substitute that here. Minus 2.5 plus 2 equal to minus 0.5 and minus 2.5 plus 3 equal to 0.5. So this becomes minus into plus, which is nothing but equal to negative. So it is not greater than 0. Now let's look at the solution. We need f of x greater than 0. So where it is greater than 0, so that means we are talking about the positive part. These two are positives. So we have to take them and union them. So solution set for f of x greater than 0 will be minus infinity. To start with minus infinity, I can go till minus 3, but I don't want to include the boundaries. So it will be closure bracket and then afterwards I'll have union. Then again I'm starting from minus 2. Minus 2 is excluded. I can go till infinity. So that's the solution set of f of x equal to x plus 2 into x plus 3 greater than 0. If you want x plus 2 into x plus 3 to be greater than 0, then the solution set is minus infinity to minus 3 or any value between minus 2 to infinity, but no values between minus 3 and minus 2 because they are negative. So this is called method of intervals or wavy curve method, because we can see that if you are able to find out one section, if it is positive, the other section automatically becomes negative, and again it becomes positive. Or can I say that whenever I cross from one 0 to the other 0, I have to go to the other side. So I start from here, I go to the other side, again I go to the other side. So this will continue. So this is one example of method of interval. Let's do one more example so that we get a little bit more clarity. Let us look at this example. 2 minus x into 5 plus x greater than 0. Now we know what we have to do. First we have to draw the number line. So let's do that. This is the number line. We have minus infinity here and we have infinity on the other side. Now let's try to put the intervals there. We know 2 minus x is equal to 0. That means one value of x is 2. Another value x plus 5 is 0. That means x is equal to minus 5. So first I will get minus 5. Then I will have 2 somewhere here. Let us say. Then we have infinity. Now what method of intervals is? First we have to find out for one value. So let us take 0. Our friend 0 is there, where it will be between minus 5 to 2. So if I substitute 0, I see 2 minus 0 is 2 into 5 plus 0, 10, which is greater than 0. That means it's positive. So by method of intervals we know if that is positive, this should be negative. This also should be negative. That's the meaning of wavy curve method. So what we know now, that you can see a wave. So it's negative, positive and negative. Now suppose we want f of x greater than 0. So what will be the solution set? It should be only between minus 5 and 2. So I'll write down minus 5 comma 2 closed interval, because the boundaries are not excluded. So let's do one more example. Now let's look at this. Our f of x is now x minus 2 whole square, x plus 3 into x minus 4. What's the difference from earlier examples? Now we have to the power of 2. That means we have a even power. Earlier they are all odd powers. Now let us see what will happen to our wavy curve method or method of intervals, how it is useful in this particular situation. So for that, again let's go back and put down our number line. Okay, this is our minus infinity and this is our infinity. What are the values of x which will make the f of x equal to 0? One x equal to 2 and x equal to minus 3. Another one is x equal to 4. So let's put them in the order. When I start from minus infinity, the first one I will be seeing is minus 3. After that I go to 2, then I go to 4. I have infinity. Okay. So now let us see what is the difference from earlier. Okay. Let us take anyway. Where is our friend 0? Somewhere here. So let's put 0 now. If I put 0, you know, anytime you square power of even, that is always positive. So don't need to worry about that. That is always positive only. So x plus 3, 0 plus 3, 3. 0 into minus 4 is minus. So this whole thing is becoming negative now. That means minus 3 to 2, it is negative. Okay. Now let us check for 2 to 4. If I check for 2 to 4, let us take a value of somewhere, value in the middle. Let us take 3 value there. Suppose I put 3, what will happen? 3 minus 2 whole square, that is nothing but positive. 3 plus 3, 6, that is positive. 3 minus 4 is minus 1. When I multiply, I am getting again negative. Oh, this is not going as per our earlier plan, right? Now I should go to the other side, but still it is continuing. Okay, let us see what happens afterwards. Now let us take any value between 4 to 5. Suppose I take any value between 4 to 5. I see that this is positive. Now let's come to this side and take minus 3 to minus infinity. Let us take one value. Suppose let us say minus 4. Now this is positive. We know x minus 2 whole square. X plus 3 is 1. 4 minus 3 and okay, well, let's take minus 4. Minus 4 plus 3 is minus 1 and this is minus. Minus into minus is plus. So we know that this is positive. Now what is the difference we observed when compared to our earlier problems? The difference is whenever the power of that particular point 0 is even, then it will continue in the same thing, it won't cross. So what happened now, we first find out that minus 3 to 2, actually we should cross 2 and we should go to 4. Now what happened now, since 2 power is even, it will continue till the next one 4. Then 4 power is odd only, so it will go. So what we understood now, if the power is even, you continue where you are. If the power is odd, you cross to the other side. Let me repeat that again. Now first we found out for 0 that minus 3 to 2, it is negative. But the 2 power is even, so we understood that that will continue in negative only. When 4 is a 0, which is nothing but with odd power, x minus 4 whole to the power of 1, then it will again become from negative to positive. So I will switch the sign whenever the power is odd. I will continue with the same one whenever the power is even. So that's the meaning of that. Let's do one more example so that we understand this new point, what we understood now, that if the power is even, we will be continuing on the same side of the number line. Now for this particular example, what is the solution we have? Let's write down that. We want to have greater than 0. So that will happen only between minus infinity to minus 3 and 4 to infinity. So whenever the values are between this, the f of x will be greater than 0. Let's do one final example before we wrap this up. Now let's look at this example. X minus 2 whole to the power of 2018 into x plus 3 whole to the power of 2017 divided by x minus 4 whole to the power of 2019 into x plus 5 whole to the power of 2020. I just created a random problem for you. So let us see now in this case what happens. Now only the thing we have to understand is, before we just go ahead and draw our number line, which we are doing now, that whenever the x value is 4 or x value is minus 5, the whole expression becomes 0, but the f of x will be undefined. So x cannot be 4 or x cannot be minus 5. So first we have to understand that. Now let's go ahead and find out where individually they will be equal to 0. X minus 2 equal to 0, so that tells me x equal to 2. So x plus 3 equal to 0, x is minus 3. X minus 4 equal to 0, x equal to 4. X plus 5 equal to 0, x equal to minus 5. Now let us put them in order. Minus infinity, after that I will have minus 5, then I will have minus 3, then I will have 2, then I will have 4. Now we have to clearly understand that whenever it is 4 or minus 5, I cannot have the value. So these two cannot have the values of 4 and minus 5. So the function cannot have the values of 4 and minus 5. Okay, fine. So let's go ahead and now try to plot it. Again, we'll go back to our friend 0 for help, where it is between minus 3 to 2, I have 0. Minus 3 to 2, I have 0. So let me go back to 0 and put 0. If I put 0, what happens? We know that any even power is always positive. So this can be ruled out. That is positive. And this is also positive. Now only left out is these two. If I take 0, 0 plus 3, 3 to the power of something is positive. 0 minus 4, that is minus 4 whole to the power of odd power is negative. That means minus 3 to 2, the function is negative. So the function is negative between minus 3 to 2. And what is the power of 2? Power of x minus 2 is even 2018, which is nothing but even power. You know, when it is even power, what will happen? When it is even power, we will continue with the same side. So I will go till 4. When I come to 4, what is the power of x minus 4? Odd. So I will go to the other side. Now only the thing, remember, the the graph exactly may not be like this. It may be anything else, but you will be switching from negative to positive, and 4 will not have the value. That's why I kept a white circle there. That means 4 cannot be one of the value. Okay, now let's come to this side. Now at minus 3, it will become positive. So minus 3 to minus 5, it should be positive. But power of x plus 5 is 2020. That is even again. So it will continue. Because what we said just now, if it is even power, it will continue. It won't cross to the other side. So I hope I am clear with that. If it is, first what we will do, we'll just directly put down all the values, whatever the values which will make that expression equal to 0, x minus 2, x plus 3, x minus 4, x plus 5. After that, we will just go to our friend 0 and ask for help. We'll find out whether that interval is negative or positive. Now according to that, we can put down all the intervals. Only the thing you have to remember, when you go from minus 3 to 2, what is x minus 2 whole to the power of? The power is how much? It is even. Even means I will be continue negative till I go to 4. Afterwards, at 4 the power is odd, so I will become positive. So this is the one point you have to understand. Now let us say for this, we have been asked to find out where the function is greater than 0. So what will be our solution set for that? Now where it is positive minus infinity to minus 3 union 4 to infinity. So 4 to infinity, but 4 is not included. Minus infinity to 3. When I do that, I can't have minus 5. So what I have to do now? I have to write down minus of 5. Because if x equal to minus 5, the whole function is not defined. So I have to do that. Whereas here 4 to infinity, it is already taken care as part of the boundary. So I don't need to worry about the 4. But this minus 5, I have to subtract here. Minus infinity to minus 3, but 5 will not be there. Union 4 to infinity. So this is about Wavy curve method or method of intervals. Now once we understand this, now are we ready to generalize this and write down? Let's go ahead and do that. Now I can say that f of x equal to, let us say suppose x minus a1 whole to the power of n1, x minus a2 whole to the power of n2, like that. And in the denominator I have x minus b1 whole to the power of m1, x minus b2 whole to the power of m2, like that, where n1, n2, m1, m2 are natural numbers, can be zeros also, and a1, a2, b1, b2s are real numbers. Can be anything. Okay, fine. Or let us say integers only for us, so that we are fine with that. Maybe okay, fine. Now in that case, now what Wavy curve method says that? Wavy curve method says that you first go ahead and plot them minus infinity to infinity. Where are the values? Let us say all of them are, we took it as, okay, let us say suppose you have all a1, a2, b1, b2. So we'll say somewhere here I have 0, then I have a1, I know the values, a2, let us say these are b1, b2, we have taken in such a order. Now it says that if in one particular, it depends upon whether n1, n2, m1, m2 are odd or even. If they are even, suppose let us say a2 is even. Let us say, oh, it's my mistake. It should be n1, n2, m1, m2, right? Oh, sorry for that. 0, n1, n2, m1, m2, where we are saying that m2 is greater than m1, m1 is greater than n2, n2 is greater than n1. These are the values we have taken. Now in such a case, suppose let us say n2 is even, and we know that 0 to n1 it is positive. If it is positive, then n1 to n2 also it will be positive. 0 to n1 it is already. So if n1 is odd, If n1 is odd power, then positive will become negative. Since n2 is even, I'll continue with that. If m1 is odd, again I will be crossing, and if m2 is odd, again I will cross. If m2 is even, I will continue. So what we can say now, two things we can say very clearly. If the power is odd, first what we will do, we'll take the number line, we'll try to find out one particular interval, positive or negative. If the power is odd, you will be crossing to other side. If the power is even, you will be continuing on the same side. This is what is Wavy curve method or method of interval. So I just try to briefly explain that with couple of examples so that you can understand it. Please do let me know your feedback. Thanks for your time and support. I'll catch you once again with another interesting topic. Till then, keep smiling and sharing. Bye for now.